So our final presenter for this session, and then we open up to your questions. Let me introduce Alex Bayen, who's here with the university and who brings with him a lot of expertise in related disciplines. And hopefully you'll give us the close that will then stimulate all the questions.
Great. Thank you very much for the introduction. Well, first I'd like to thank the organizers of the conference, Paul Wright and Hugh Altridge. Hugh has put enormous amounts of work in making this work, so thank you. So I'm going to talk about how technology and specifically crowdsourcing data has revolutionized mobility and that has dramatic impacts on next generation cities. For those of us who live in cities, and particularly for those of us who live in agglomerations like in the Bay Area, we were used, I should say, a couple years ago to very primitive forms of information for mobility. If you were living in San Francisco at the time, or in Berkeley, and you would have wanted to go to San Francisco, you would typically have looked at these signs or these very primitive websites, which at the time were just giving information on the major freeways. And that's mainly because the infrastructure we have developed in our cities are hardware-based and very expensive to put in place. You've a lot of loops, and we've heard from Orange this morning, and the similar infrastructure is also in place in Europe. That's maybe the next generation loops, which is wireless, and that also counts cars, cameras. But the bottom line is all of this is extremely expensive to deploy. And I think what's striking, and I love to show this graph, and I apologize for the clarity of the axis labels here, is amazing is if you see the growth of electric devices and electronic devices we carry around, you can probably see this little thing here, and actually it's a bit cut, but that curve here, which goes up to almost 1 million, is the number of Androids on the planet. Today, in 2012, we have up to 1 million activation Androids a day. So you can imagine the scales at which these things are exploding. And of course, this has a very interesting impact on mobility. And so, the title of the conference was, what's the added value? And I thought this would be a very good graphical way to show what is the added value of technology for one very specific problem, which is traffic information. So this is what could be considered a vintage website, which would show you, the traffic information at the age of before the smartphone explosion. And this is what you're probably not even thinking about now when you look at Google traffic on your smartphone, which is mainly due to the fact that all of us are contributors of data to this enormous system. And Google is one system, and Microsoft has another system, and Telenav and Navtec have another system. So it's something which has been fairly mature. And so I'd like to tell a little bit of the story of the genesis of these systems, which will show us how the city is evolving and hopefully will lead us to the future. So Mobile Millennium was one of the systems that was developed at Berkeley together with Nokia. It was the first traffic information system relying on GPS-enabled smartphones that was ever deployed in North America and run on all the Symbian and RIM phones. At the time, it was a big deal to have 5,000 downloads. Of course, at the era of the App Store and the Google Play, the scales have changed. But the bottom line is that it enabled us to create a research architecture on which we can now test a lot of the different algorithms that are equipping these systems. And also generic enough that it can be deployed in various cities of the world. And in particular, we have also worked with Stockholm, which is using our system. And so the question you're probably asking yourself is, how can this crowdsourced data be used, and what can be done with it, and what about privacy? And so first, I thought I'd first show you a snippet of what the data looks like. So this is an example of what 500 vehicles can gather. It's basically 0.5% of the data the system is gathering today, and this is probably a tiny, tiny proportion of what companies like Google or others are gathering here. Every taxi in the city is sending us one GPS point every minute. I mean, think your phone is actually sending probably a GPS track every 3 to 4 seconds, whatever provider you're using, whatever brand you're using, whatever app you're using. So this is extremely small compared to what's already there. And you can see it's already amazing that after a couple seconds of playing that data, you can practically see the map of the city just from the data. And just to give you a sense of what it would look like if I let the movie play longer, the amount of data you're getting is astronomical. And I really want to emphasize this, that this is really a tiny, tiny bit of the data that is available today. And just that data from the taxi is already enormous values. So in a sense, this is what would be the paradise of I know it sounds very boring. It's what would look like the paradise of a traffic engineer. Basically, what you have here is time. What you have here is post mile on a highway. So this is the distance on a highway. And each point is a GPS track. Okay, so if you sample every car every 2 to 3 seconds, that's basically you driving on the freeway with a phone. You're sending that data, whether you know it or not, or whether you want it or not. Submits that data to someone, that someone being Google or another entity. Typically what you can see is with 2 to 3% of people sending that data, you can practically see everything which is happening on the freeway. You can see these people going really fast, bumping into a traffic jam, and then going slower, and then going fast again. So, of course, there's a lot of data analytics that goes behind it. And in practice, life is not as nice. What you get is more something like this, so less data, from which you have to reconstruct this, which looks pretty much close to the reality. And so part of the work that will really revolutionize mobility in urban environments is specifically how you go from here to here. And that's exactly what a lot of people working on large-scale data analytics do today. Now, what about privacy? I mean, so you could think about there's a little bit of a problem. If I can track everything you're doing, I can track speed violations, and I can track a lot of other not-so-cool things for you to disclose. And so one of the questions that was asked before is, how you do this in privacy-preserving environments. And there are many ways to do this. One way that Nokia thought about is about, every time you run an app, in a sense, you're querying some database that provides you a map and a lot of information. So if instead of leaving behind you a track of points, you were just checking in at some location which is predefined and embedded in the map, then you can send data somewhat probabilistically in a way that is not as privacy intrusive and still helps engineers like me build traffic information systems or other applications. And so I think, without going into further details, I think I just wanted to show this slide to give a sense of what can be done in terms of privacy preservation, because revealing your traces all the time is probably not something you want to do, even though you're probably doing it without knowing it. So the future of mobility and the future of traffic information won't rely just on phones. The point of large-scale data is that it will also rely on the fusion of extremely large data sets. And I want to show things we're doing here to give you a sense. I mean, the classical things is what we've been doing for 30 years, and that would be basically cameras, loops, and radars. The more modern or new things we're doing is maybe using the fast track or RFID tags, the taxis, the phones, the aftermarket devices. But it's not completely crazy, especially if you're dealing with planning, to think that people are flying planes. This is aircraft data. I mean, today Google is flying planes to just monitor areas and create maps. So you could do the same for traffic. In fact, people have been doing it for a while on the radios, for the radio stations, and even satellites. This is an example of satellite data that we've gotten from the DLR, which has basically reprogrammed the satellite to orbit around California from some experiments. So the point here to show this is that we started from very basic infrastructure for the cities, but tomorrow's planning and tomorrow's operations will rely not only on very novel sources of data, but also on the fusion of all of this. And this is where the difficulty and, incidentally, all the fun is as well. Now, an interesting thing is, from a data perspective, if you're a city, you'd like to buy that data or get that data. The problem is that data is in the private sector, which means there needs to be procedures for the data to be procured. And so type of things we do is work with the state of California to help them with their procurement procedures so that they can buy private sector data, which in general will be much cheaper than deploying further infrastructure. So in that case here, thank you, this is an example of data we're getting, which shows the number of GPS points per certain location, and that's the type of thing that you can do to define these procedures. And so there is a lot of questions all around the world about cities. Is, how are cities going to acquire their data? The one thing I wanted to show, since we had a nice Bruce Willis movie cover, is to show the Italian Job, because in the Italian Jobs, for those of you who have seen that movie, Seth Green basically takes over control of an entire traffic control system for LA. And it is kind of what we want to do, except the goal is not to steal gold and create massive traffic jams, but basically to help traffic flow better in cities. And so when you think about taking over an infrastructure, such as the one of suburban areas like we have here, I think what you're thinking to do is to basically look at ramp meters and changeable message signs and interface these hardware infrastructure with information you deliver on the smartphones. And so in building that system, what that means is you're building a system which swallows enormous amounts of data and uses it to advise people, because it's not going to be automated overnight, to enforce policies which help traffic flow better. And things we're very interested to work on, and Hugh has been instrumental in building partnerships between San Francisco and Paris, and hopefully soon with Fresno, is to see how we can use this for improving air quality and it being really related to traffic. And this is not just a technical challenge. If you think about next generation cities, I mean, it's really about having agencies such as the DOTs and MPOs and the counties and the cities themselves involved together institutionally to work together with the commuters, with transit agencies, with people who own the infrastructure, which might be in the private sector, or selling that data. And so it's not just a logistics problem. It's not just a technical problem or research problem. It's really an institutional problem. And this is really, in a sense, having a diagram like this, which works for your city, is really where the future of its operations lies. Just to finish, the one thing I want to show, and this is courtesy of my colleague Edmund Seto, is that once you have reconstructed traffic to a certain extent, it becomes easier to do things like noise maps, which are also extremely important to the quality of life in urban settings, or even emissions, because it's not going to be a couple years before phones can measure air quality. I mean, it will happen ultimately, but it will not happen overnight. And so in the middle, in the meantime, what you need to do really is to figure out models that can predict that. And so I think I'm going to stop here, but maybe the one conclusion I want to show, and again, maybe going back to one of my very first slides, is that at the end of the day, traffic information systems were the first beneficiaries of this revolution, and that's because it was market-driven. So very quickly, the entire private sector rushed on this, because if you owned traffic information, you owned guidance, navigation, turn by turn, and with that, localized advertisement, and that war is still ongoing. This is the first of many to happen, and I think the cities have an essential role to play in defining what the future revolutions of this type will be. So I look forward to talking more about this in the panel. And again, thank you very much for the invitation.
Thank you, Alex.